So hi guys, so today we would be starting with some machine learning theory. These are some theoretical topics that ones need to know. I was explaining the research papers from past few days, but I thought that there are some topics that are some specific theoretical topics that ones need to know before they go deep into research papers and deep into frameworks. So we would be starting off with supervised learning. This is a very basic theoretical part and a practical part also in machine learning. So as you can see from this image, just forget for a minute that you are learning something related to machine learning or AI. Just imagine this is your brain and this is these are apples. You were small and you don't know about anything about them. These are apples and these are the labels that have been given to you, okay, that these are apples. Now after 1 hour 2 hour or after few days, someone asks you that what are these, you would immediately said that it's apples. So why, how is that possible? Because you were told that this is the data and this is the label, and now you have to tell what this is. So I would just show you another example. Suppose I would just take a pen here, and this is a very big data set in which this is a cat. There are images of cat. These are all images of cat. This is image of dogs. Means there are hundred and thousands of images of dogs, and now I have fed that to my model, and now I am asking my model that tell me the image that I am giving to you, is that of a cat or of a dog. The model would simply say that it is of a cat. There are chances that it may go wrong, but if you have given it a clean data and generous data that is really important, then 99% chances are that it would respond correctly. So this is supervised learning. The training data you feed to the algorithm includes the desired solution called labels. So this was the label that I gave to the model, that is cat and the dog. So the what is the goal of a supervised learning? So the goal of a supervised learning algorithm is to use the dataset to produce a model that takes a feature vector. So there are a lot of features inside this cat image. Suppose this is so this is an ear, this is another ear, these are eyes, and a lot of features are included inside an image, and from that model learns that okay, this particular feature is of this label, and this particular feature, suppose this tail is a feature of this label, that is dog. So it takes a feature vector x as input and output information that allows deducing the label for the feature vector. So if an example that big tech companies used in real life related to supervised learning is a famous one, that is the spam emails. You every day, if you use Gmail, you must be knowing that there is a separate column related to spam emails. So how is that possible? So this is a very big data set in which Google has told the algorithm that all the emails which we are giving to you in this data set are spam emails, and all these emails include some wordings like some wordings like 50% off or 60%, something like that. And because usually these emails that are related to offers and all, or any scheme, are considered as spam. Now the algorithm learns from it, okay, these are the emails that are spam. And after that the algorithm learns, and after that when a mail comes into your mail ID, the algorithm would work through that mail. Okay, is this mail a spam mail or is it a non-spam mail? And when it realizes okay, it contains some features of these mails that I have already learned from the dataset, it would put that mail into a spam email section. And if it is not, then it would put your mail in the normal inbox section in which you can view it. There are many cases in which the algorithm fails to do that, and that is what we call classification. This whole part in which we differentiated between two specific classes or more specific classes is called classification, which is our application of supervised learning. There are basically two famous applications of supervised learning. One is classification that I just told you, and another is regression. But before moving to regression, let's understand this classification graph. So suppose these green dots are spam mails, and these blue dots are non-spam emails. Now you can see this is the line that is known as the decision boundary that is differentiating between the two specific classes, that is the spam emails and non-spam emails. In this you can even see that there are small errors in this. Obviously it's a machine learning algorithm, it can do sometimes, it can make mistakes. You must have seen in your real life examples that I told you of email, that some important emails are also coming to the spam part, or some spam emails are also coming to the inbox part. So yeah, it's possible, but a majority emails you can see here are working fine, they are going to their respective classes. So this is the classification graph in which this is the decision boundary that is differentiating between the two classes. Now coming to the second part, that is regression. So this is another typical task, that is to produce a specific target numerical value. An example that I would like to give you all here is, suppose there I am looking to buy a car, and I gave my model a data set which contains price of a car, which contains features such as mileage and the age of the car, and I also give it the brand of the car. Now my model would learn through it that graphs go something like this, that the better the brand, the higher the price would go, the better the less the age, the higher the price would go, and the more features, like the better mileage the car is giving to you, the more higher the price would rise. Now after that I would tell my model to specifically tell me what is the price of this specific car. So now that part is known as regression, that we are asking up to predict a target numerical value. So the graph here you can see, here you can see the regression graph, that the values have been plotted against it, near it, and you can predict what is the specific value of a particular car, or any real life example you can work on. So here one thing to note between both of these things, classification and regression, that some regression algorithms are also used for classification, as well as some classification models are also used for regression. For example, now suppose I created an object detection model, that is let that be an easy one. I created an email spam filter that tells me what is the number of percentage chances that the following email is a spam email, and no, a percent of chances that is not. So now this model will show me something like that, that this was my email, and 20% chances are there that this email is a spam email, and 80% chances are there that this email is not a spam email. So this is how both the algorithms are working simultaneously together, that is regression and classification. So this is how supervised learning works. I would again repeat that in supervised learning, the training data you feed to the algorithm includes the desired solutions called labels. So yeah, this is how the whole supervised learning part is working. I tried to cover this as easy as possible, and in the shortest time available, so that the video becomes quite interesting to watch. So thank you and have a nice day.